afternoon, everyone. My name's Graham Holt from the Daitan group. So today I decided not to do a live demo, but what I wanted to do was share some of our development experiences and talk a little bit about the type of things that you're going to need to think about if you're building out some sort of WebRTC solution. So we did actually build a demo for ourselves based on a combination of WebRTC, IMS, FreeSwitch, and using an NFV approach. One of the problems we have as a company is we're a software services company. So we don't have a product of our own, we don't have service or platform of our own, but we build these things for other people. So it gives us a couple of problems. One being we can't really talk about the projects we've developed for others. And the second being we need to be able to talk about WebRTC and show people what some of the challenges are going to be. So we built out this demo. We've been working with WebRTC for around about 18 months. And the demo is really built around most of the most common questions that people come to us with. So when they're coming with their challenges, what they're describing in their WebRTC projects. So we built this demo to be able to show the type of things that they're going to have to think about and maybe the places that we can help them. OK, so what the demo does, we implemented a pretty simple thing. It's a chat room, so a video chat room that supports 5 people. It works on PCs and Macs and mobile devices using just the Chrome browser. OK, so there's no mobile libraries. It's just using the native support on the mobile browsers. So we've got audio and video, we've got a messaging session there, and screen share. And that's all pretty straightforward to do with WebRTC. So this is, these are all the things that WebRTC gives you. Where it starts to get a bit more complex is when people want to integrate with existing infrastructure. So typically they want to interoperate with existing SIP phones or SIP infrastructure, or be able to do the dial-in, dial-out to PSTN. And that's when it starts to get a bit more complicated and you need a little bit more infrastructure in the background to do those sort of things. Okay, so this demo is built, in terms of technology, we're using FreeSwitch, we're using Clearwater IMS, which is an open source IMS core, and we're running this on Amazon Web Services. And everything we're doing is using open source components, and we're really just providing the glue to put that together. Okay, so I put a couple of scenarios that we've worked on. So this first one is probably the most simple case when you need the interoperability. And again, if you don't need to interoperate with anything else, this is a much simpler problem. Okay, you can have everything can be pure WebRTC and web servers in the background. But here we specifically wanted to be able to integrate with PSTN calls and also with SIP clients. So down in the bottom, we've got all the different clients. On the WebRTC client side, when we built that, we chose to put SIP in the endpoint. Okay, so we're using a JavaScript SIP library there. A lot of people, they're going to say, don't use SIP in the endpoint. Okay, implement your own proprietary protocols there for signaling. The reason we tend to go with SIP is probably mostly because most of our customers tend to be coming from the telecom and communication space. And when you look at the use cases, they start out pretty simple. So I just need to be able to register, start a call, hang up a call. But then as they get more users, particularly business users, they want to add people, do multi-party conferences, and a lot of the other signaling and negotiations that happen during a business-type conversation. So we found that in a lot of cases, you end up almost reinventing SIP with a proprietary messaging protocol there. So one easy way is there's a lot of SIP libraries available that'll run in the browser, so that's one way to solve that. I think more on the top side, in terms of what you need in the network, we have the application server is basically serving out the web application, and this can do whatever you want. So in our case, we implemented the 5-party video chat room, but it could do any other application you wanted. And then in this particular case, we put FreeSwitch in there. We tend to use FreeSwitch quite a lot in our projects. And in this case, it's playing 2 roles. One is of the call manager. So it's handling the setup and teardown of calls, registering users, and so on. And it's also, we're using the media server. And we did that, particularly when you're doing the interworking, you will need to do some media transformations. Okay, so you need some sort of media service or server there to help you do some of that transcoding and transformations that need to happen. And we actually extended FreeSwitch. Natively, it's going to support audio transcoding in the media server. And we did a little extension to support video codecs there as well. I would say this is probably more a proof of concept or for small-scale deployments. It's certainly wasn't built to be a large-scale media server. So your FreeSwitch can play a role in these type of solutions, and we find it pretty useful. There's some good tools in there. But if you're looking at something larger scale, then you need something more like this scenario 2, which I'm going to show you in a second. Okay, just a quick reference there to what happens in the signaling and the media side. So across the top, we've got the signaling represented. And basically, in this case, because we're using SIP in the endpoint, we're going SIP over WebSockets. The first thing you need to do is get that out of WebSockets and put it into UDP so you can talk SIP to other devices in the network, specifically to FreeSwitch in this case. And you'll need to do some transformations there, particularly if you're going to be interoperating with PSTN, with other SIP clients. What we found is the SDP, you need to do some manipulation just to negotiate the media stream correctly and so on. And then in the bottom, we're dealing with the media. And where you can, you want to avoid any transcoding needs. Okay, so if you can run VP8 all the way through, that's going to be great. Same on the audio side, but usually we're getting into scenarios where we need to do some sort of transcoding. And then a solution like this isn't going to be great because this is using FreeSwitch, which wasn't really designed to do video transcoding. Okay, so there's going to be some pretty major limitations in that case. So that led us to the next scenario where we started to introduce a more high-quality media server. So in this case, we're actually partnering with Dialogic to integrate their media server into the demo. And the sort of use cases that this extends to, if you want to go from point-to-point or mesh calls up into a true hosted multi-party video session, then you're going to need something like Dialogic media server or like some of the open source media servers maybe that we're also working with. If you want to do call recording, some of the more advanced features, ad insertion, these are all things where you need to start to manipulate the media streams. And in that case, you want to be looking for some sort of professional quality media server to put into the environment there. Or you can start with the open source versions and do the modifications. So it's pretty much the same functionality. It's just that we'll get a lot more performance from a solution like this. And we'll be able to have a lot more flexibility in terms of being able to record calls, be able to insert ads, and so on. And on the signaling and media side, it's pretty much the same. The main difference is that the media handling has now been taken away from FreeSwitch, and we put that into the Dialogic media server. Okay, so it's really being handled by an element in the network that's much more capable of doing that work than maybe FreeSwitch is. Okay, so in terms of challenges, the message that we keep repeating to people, or the story we keep having to tell people is, if you're building a simple WebRTC application where you can contain the world within WebRTC, so you've got the whole environment under your control, you're probably going to be okay. You've got to think about scaling, you've got to think about quality, but WebRTC handles those things pretty well. As soon as you start to go outside of that norm, though, if you want to interoperate with other type of endpoints, I talked about SIP devices and PSTN. We've done some integrations with Microsoft Link, which that gets even more interesting. But any of those scenarios, you need a lot more infrastructure in the network. So you've really got to think about what's your high-quality network going to look like in the background that's going to support that WebRTC service. Okay, so the service is obviously a much bigger thing than just the WebRTC, which is a particular part of the solution that you're putting together. And these are the things that we come across. So it's interoperability, quality, scaling, performance, and so on. Okay, I think just a final note. I mentioned IMS. We did start working about a year ago with Clearwater, which is an open source IMS implementation. We're seeing that as a pretty good option for some sort of base system, particularly if you want to be able to scale out more than you would be able to do with something like a free switch type solution. Okay, so it's got the scaling built in. So that's something that we're starting to play with and incorporating some of our projects now. And I'd recommend people to start to take a look at that. Okay, so that was a very quick sharing of some of our experiences. I think we're here at table 205. So if you've got some project ideas in mind, you want to have some help about how you might go about doing that, please come along, have a chat with us, and we'll see if we can help you. Okay, thank you very much.